Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Hamadi Muhammad Ali. My metric number is 226733.
Hi, my name is Nura Aura Inshira binti Bisola Hakimi. So my matrix number 229594.
My name is Shashan Edina binti Hazmahandi and my metric number is 228152.
Today I'm going to talk about the significance of refractory and noble metals in industrial application. This is engineering materials first semester project. Yes. So metals are fascinating elements that make up much of our modern world. Today, we're diving into two important categories: noble metals and refractory metals. Let's explore what makes them unique and why they matter. First up, noble metals. These are like silver, platinum, gold. What makes them noble is their remarkable resistance to corrosion and oxidation. While most metals react to air or water over time, noble metals stay pristine, even in harsh environments. You've probably seen noble metals in jewelry stores, coins, but did you know they also in vital electronics? Gold, for example, it is used in circuit boards because it's an excellent conductor and doesn't tarnish. Now, let's talk about refractory metals. These are like these metals are like tungsten, molybdenum, and tantalum. They claim their fame. They can withstand extremely high temperatures. We're talking over 2000 degrees Celsius in some cases. Refractory metals are critical in industries where heat resistance and strength are the key. Think about jet engines, spacecrafts, and even surgical tools. Tungsten, for instance, is famous for its use in light bulbs, where you can find it everywhere, and cutting tools. So, how are these two types of metal different? Noble metals excels in chemical stability and beauty, while refractory metals shine in durability and heat resistance. Both are indispensable in modern technology, from the elegance of noble metal to the resilience of refractory metals. These elements are crucial to industrial and innovation worldwide. Next time you see a piece of jewelry or hear about spacecraft, you'll know the science behind it. Thank you, everyone. This is the introduction to the our project. I'm gonna leave you with the next. I'm gonna leave with my partners explain more of it in some more detailed ways.
Okay, next is refractory metals for industrial application. First is aerospace and defense. Melting point. Important for high temperature applications such as re-entry vehicles, jet engine, and rocket. From this, it explained that you can prevent engine to degenerate or melting in the extreme heat produced during flight. Plus, it's not going to lose any structural strength. Next is mechanical strength. Maintain their strength in the face of severe pressure and stress, and which is essential for aerospace parts that are subjected to high G-force vibration and temperature changes, and it won't break under extreme pressure. And ensure the safety of the flight. Next is radiation resistant. Its ability to resist radiation damage is essential for the long-term operation of reactors, and it's preserve their effectiveness and security when deployed in radiation-exposed area. Can safeguarding fragile electronic components and structure elements, maintaining space equipment ability to operate in difficult space condition. So based on this, and it's it's suitable for this aerospace and defense because it can resist radiation damage. Next is corrosion and wear resistance. Guarantee that even after extended use under extreme stress, This part will maintain their shape and functionality, and it help protect sensitive system or absorbing and blocking the radiation. Uh, Radiation exposure in space or defense operation or can compromise the integrity of electronics or structural materials. Metals preserve Refractory metals preserve the functionality of critical system. Next is application chemical process. Corrosion resistance. It can extend the lifespan of equipment like reactors, heat exchangers, and pipelines. Maintaining the integrity of processing equipment ensure uninterrupted chemical reaction, increasing efficiency and reducing product contamination. Prevents equipment failures that could cause dangerous leak, explosion, or contamination, resulting in a safer working environment. Next is high melting point. It's same as a and aerospace function. It's when high melting point, it can maintain the mechanical quality such as strength and ductility at far greater temperature than other metals, and it can be something that we can put as a container to put any hot chemical reaction without make the container it won't break because it's high melting point for this is for application chemical process for refractory metals industry. Okay, lastly, significant refractory of industry application is electronics components. High thermal conductivity. It allows the heat generated by high-speed processing to be rapidly dissipated, preventing the degradation of the IC functionality. Allows to move heat away from sensitive components, preventing overheating and ensuring stable performance. So when high thermal conductivity, even in high temperature, it can prevent any overheating, and it can ensure the performance of that functionality for the components of electronic component. So next is mechanical strength. Can withstand vibration, heat expansion, and thermal cycling without breaking or deforming. Prevent electrical device components from failing when subjected to stress, shock, and vibration. Strength guarantee the packaging of functionality and integrity, avoiding failure in the field or during manufacturing. Means like it's when mechanical strength, it's if anything happen if with high vibration, high heat expansion, and thermal cycling without breaking or deforming. Next is oxidation and corrosion resistance. Extremely oxidation resistant, preserving the dependability and durability of high performance part. And if exposed to air, it forms a highly protective oxide layer on the surface, making it highly corrosion resistant in both electrochemical and oxidative situation. So next, I will pass to Shasha to explain about noble metal.
Okay, moving on to my section, which is the significance of noble metals in industrial application. For the first section, which is the noble metals in electronics in electrical industry. So first, let's talk about electronics. So have you guys ever wondered what makes our phone, laptop, or even our TV work so smoothly? Well, a lot of it has related to the noble metals. So these metals, like for example gold, silver, and palladium, are essential because they are good at conducting electricity, and also they don't rust or corrode easily. So that means they are perfect for the technology that needs to last and perform under stress, which is we can take gold for example, which is commonly used in connectors, switches, and also circuit boards. Why? Because gold doesn't corrode or tarnish, which means it helps to keep everything running smoothly for a long time. Even though gold is more expensive, it's worth the cost because of its critical application, where long-term reliability is a must. So then we move on to the silver, which is actually the best conductor of electricity out of all metals. It's used in electrical contacts and other components where we want the performance to be absolutely excellent, and also the gadgets that need to transfer power or signals without any loss. So silver might be a little more affordable than gold, but it's still super valuable for its performance. And lastly, for palladium, which is we kind of Wherefore we listen about palladium. So palladium, this metal is a key in the multi-layer ceramic capacitor, which is the short form is MLCCs, which are almost every modern electronic device have. So they help store and release electrical energy, and without them, our devices wouldn't work the way they do. So in fact, the demand for palladium has been rising with the increasing need for advanced electronics, especially in mobile devices and also computers that we always use. Okay, so I will be talking about noble metals in aerospace and defense. So for this industry that always depends on this metal, we are talking about some tough stuff, which is because noble metals like rhodium, platinum, and iridium are used in some of the highest performance applications out there. So we can start the first one with rhodium, which is this metal is used in thermal protection system for spacecraft and also jet engines because it can handle extreme temperatures. That means when a spacecraft re-enters Earth's atmosphere or a jet engine is running at full power, rhodium will keep things cool and safe. This is because rhodium has high melting point and also has the ability to reflect heat, which make it a perfect fit for a high stress environment. So for the platinum and iridium, both of these are used in spark plugs and other critical components in high performance engines. They can withstand intense heat and stress without wearing out, which is a big deal when you're dealing with extreme conditions like those in aerospace industry. So in fact, platinum is often used in fuel cells for spacecraft where its stability is the crucial thing to build the spacecraft. So lastly, in the defense industry, iridium is used in important applications like satellite communication and also guidance system, where it's resistant to corrosion and high temperature stability are so essential for keeping everything running smoothly in the harshest environments. But not least, I will be talking about the significance of noble metals in medicine. So can you guys believe that noble metals are super important in medical devices and treatments? For example, platinum and gold are two of the most commonly used metals here because they are biocompatible, which just means they don't cause negative reactions in the body. So for the first one, we will take gold for example. Besides being as our accessories, gold is also used in medical devices like pacemakers and also surgical instruments. It's also found in some diagnostic devices like sensors, and is even used in dentistry because of its antibacterial. Plus, gold's malleability makes it perfect for precision medical work. And for the second one, which is platinum, is not just used in devices. It's also the base for some important cancer treatments. For example, like a platinum-based drug, which is the name is cisplatin, is used to treat cancer because it can damage the DNA in cancer cells, which we can prevent them from growing and spreading. This has been a game changer in cancer therapies, especially for cancers like testicular and ovarian cancer. So for the extra information, which is silver, is also used in medicine like silver nitrate, which is used as eye drops for newborn babies to prevent eye infections. Silver's antibacterial properties also make it a key ingredient in wound dressings and other medical devices, which is helping to prevent infections in patients. And for the lastly, even uranium, another noble metal also, is used in cancer treatments, specifically for liver cancer, making it essential in the fight against various forms of cancer. That's all for me.